Hello, period 1. Today we are going to continue talking about stoichiometry. Please pause the video anytime I ask you to so that you can work out the problem and just restart it as soon as you are ready to look at the answer. Alright, so don't forget, when we have a balanced equation, we are looking at a lot of information. So it's telling us information about kind of the amounts of molecules of each of these substances that is required. And then we can take that and use or multiply that by anything. So we can say, instead of it just being 1 molecule of carbon monoxide, we could say 1 mole of carbon dioxide reacts with 2 moles of hydrogen gas to produce 1 mole of methanol. Okay, so a lot of information is given by chemical equations. And don't forget that besides those mole ratios that are established by that balanced equation, the other place that we've seen moles is we've taken moles and we've converted them into number of molecules. So in 1 mole of some substance, there's 6.022 times 10 to the 23rd molecules. And we've also taken moles and converted that into grams. So for example, in 1 mole of water, there are around 18 grams of water. Because what we need to do is take that molar mass of water, so we take the mass of oxygen, which is about 16, and then add up that mass of hydrogen, which is 2 each. So 16 plus hydrogen 1 plus another hydrogen 2, to give us a total of 18 grams of water in 1 mole. So now what we are going to start to do is take that a step further, kind of put all that together. So this is one we went over the other day. So what mass of oxygen will be required to react exactly with 44.1 grams of propane? Here is your equation. Don't forget that it's already balanced. So what we know is that there's 44.1 grams of propane, and what we need to find out are how many grams of oxygen would be required. And so in order to figure that out, what we need to do is do all of this, which seems like a lot, but when you're using those railroad tracks, it makes it much easier. So we start with our mass of propane, 44.1, and we convert that into moles. And so this is something we've been doing all along. Once I know the molar mass of here, I can say that, well, I can use that conversion in 1 mole of something. There's this many grams of propane. We're then going to convert that into moles of oxygen using that mole ratio. So 1 mole propane, there's 5 moles of oxygen. And then we're going to take the moles of oxygen and convert it back into grams. And so I can figure out what that molar mass of oxygen is, and I can use that conversion. 1 mole of oxygen is equal to the molar mass of oxygen weighed out in grams. And so here are those steps. Always, always, always make sure you balance not only just the each of the chemical formulas, but also the entire chemical equation. So keep practicing on those chemical formulas. That's where many of you still need a little bit of help. All right, so then next you're going to convert mass of substance A into moles of substance A. You are going to set up those mole ratios using the balanced equation. Use that mole ratio to figure out how many moles of substance B there are, and then convert moles of B back into mass of B. And so we're going to go over some examples of this so it's not as confusing. But basically what you're doing is referred to as stoichiometry. So you're using those balanced chemical equations to figure out the relative amounts, and then also masses, which is what we're starting today, of the different products and reactants that are involved in those equations. All right, so here is our first practice problem. Iron 2 oxide reacts with carbon to form iron and carbon dioxide. Calculate how many moles of carbon dioxide would be produced if 1.5 moles of iron 2 oxide is completely used up. So at this point, I want you to pause, and I want you to figure out the chemical equations or the chemical formulas for each of these substances. And I also want you to attempt to balance that equation. So go ahead and pause now. All right, so hopefully you have this as your chemical equation. You'll notice I didn't balance it for you because I want you to balance it on your own. So if you still haven't balanced that, please go ahead and pause and balance this now. And so what you all are going to do now that you're back with that balanced equation is you're going to calculate how many moles of carbon dioxide would be produced if 1.5 moles of iron 2 oxide is completely used up. So we know we have 1.5 moles of this. We're going to use that mole ratio to figure out how many moles of this we have. Again, my equation isn't balanced, so if you haven't balanced yours, go ahead and do so now. All right, so here's that problem. Here's my unbalanced equation. Don't forget to balance yours. And these are the steps I would use. So we always start with what we're given, 1.5 moles. I'm specifically going to add the FeO, the iron 2 oxide here. And so here's my mole ratio. I know that there's 2 moles of iron 2 oxide for every 1 mole of carbon dioxide. And this is established by that balanced equation. Mine, again, is not balanced. So you multiply across the top, you divide by the bottom, and now we know the moles of carbon dioxide. Whoops, I don't know what's happening. Okay, so for this second problem, we have chlorine gas reacts with potassium iodide to form potassium chloride and iodine. So calculate how many moles of iodine would be produced if 4 moles of potassium iodide are used up. And so again, here I want you to figure out the formula for each of these, and I want you to balance this equation. So go ahead and pause now so you have time to do that. All right, so here are the different formulas. Again, I did not balance my equation. That is something you all need to do. So if you haven't done that, make sure you do. But don't forget, we're going to figure out how many moles of iodine would be produced if we start with 4 moles of potassium iodide. So for this problem, again, we are always going to start with what we're given. So 4 moles of potassium iodide. Don't forget to write the Ki here. Using that balanced equation, we're going to use this mole ratio. So for every 2 moles of Ki, there should be 1 mole of iodine. And then we just multiply across the top, divide by the bottom, and we have 2 moles of iodide. Don't forget this mole and this mole here would cancel. All right, so for these next two, I believe I'm giving you the equation because they're a little bit trickier. We're now taking it a step further. So we have ammonia is reacting with oxygen to form nitrogen monoxide and water. If you have 85.15 grams of ammonia, how many grams of nitrogen monoxide would be produced? So again, the first thing you all need to do is balance that equation. And so we are going to take this step by step, and I will explain it as it goes on, but go ahead and pause to balance that equation right now. All right, so we're back. Again, I did not balance my equation, and I truthfully can't figure out how to draw on this. So we are not going to. So what you all are going to do is you're going to start with what you're given. So we were given, and mine is all going to appear at the same time. There's no way around it. But we were given 85.15 grams of ammonia. So what we need to do is we need to cancel this. And so the conversion that we can use is that mole conversion that we've been using for the past few weeks. So I know in 1 mole of ammonia, there's 17.03, roughly, I think I rounded mine a little, grams of ammonia. And so now these units would cancel. So now I'm in moles of ammonia, but I still need to get to grams of nitrogen monoxide. So this is where I use that mole ratio from that balanced equation. When there's 4 moles of ammonia for every 4 moles of nitrogen monoxide. Again, moles here would cancel. Now I'm at moles of nitrogen monoxide, but I still need to get to grams. So now I convert that back into grams. So 1 mole nitrogen monoxide, 30 grams, which is the molar mass of nitrogen monoxide. These cancel, these cancel, these cancel, and all I'm left with is this here, grams of nitrogen monoxide. So you multiply across the top, divide all the way by the bottom, and you should get, I believe, 150 grams of nitrogen monoxide. One helpful hint, because I'm not sure what sort of calculator you have at home with you, when you multiply across the top, just write the answer right here. Multiply all the bottom, write the answer right here. Take your top, divide by your answer on the bottom, and you should get 150 grams. All right, so one more practice problem. Here we have iron. It's reacting with chlorine to form iron 3 chloride. So it says if you have 177.25 grams of chlorine gas, how many grams of iron 3 chloride would be produced? So what you all need to do first is go ahead and pause and balance this equation. All right, so now that you have your balanced equation, let's go ahead and look at the answer. Actually, go ahead and pause and try to solve this first. Okay, so think of that last problem, kind of go through those entire steps. So go ahead and pause and try to solve for grams of iron 3 chloride. All right, so here is our equation. So we start again with what we're given, our grams of chlorine. We use that molar mass of chlorine, which would be converted into 1 mole of chlorine gas. We use that mole ratio established by that balanced chemical equation, so 3 moles of chlorine for every 2 moles of iron 3 chloride. And then we go back to grams. So in 1 mole, I know that there's the molar mass of iron 3 chloride in grams. So again, if you're looking at things canceling, these cancel here, these cancel here, these cancel here. So all I'm left with is multiplying across the top. The units here would be grams of iron 3 chloride, and then divide by the bottom. And so I believe you should get the 405.5 grams of iron 3 chloride. All right, so today, besides watching this video, what I need you all to do is finish the first 3 pages of that stoichiometry foldable. And then I want you to work on those stoichiometry practice problems that I'm posting on Google Classroom right now. And then don't forget to make sure you're also getting started reading Chapter 9 in your textbook. Please let me know, write down any questions, let me know if you have any. You should be able to contact me via Remind. And I will see you all again on Thursday. Don't forget, on Thursday I will have some online office hours if you all need to ask questions or if you want to go over any practice problems. See you soon, and stay healthy, everyone. Take care.